Hi, my name is Vish Banerjee. Today I'm going to show how to optimize one variable to influence the other. So in this video, I will be optimizing the unit price of a product to maximize its gross margin. So to do that, I have set up a use case. So there's a company called Beta Cosmetics, and they're in business of manufacturing personal care products. And in their hair care division, they have three very high performing shampoos, A, B, and C. And seeing the success of these shampoos, they've decided to launch another variant called X. Now, they have to set the price of X in such a way that the gross margin of X is maximized at the time of its launch. So here we are going with some assumptions. So assumption is the shampoo X is very similar to A, B, and C. So that means the customer's response to the price of X is going to be similar to that of A, B, and C. Or in other words, the price elasticity of demand of X is going to be similar to that of shampoo A, B, and C. Now, we also need some data points, which we already have, and those are the launch prices of A, B, and C, and the quantities that were sold at those prices, and the unit cost of shampoo X. And we're also setting up some constraints. So the first constraint is the gross margin of X at the time of its launch cannot exceed more than 70%. It can be 70%, but it cannot exceed. And that too, provided its sales price with that margin is not exceeding the sales price of the competitor's similar product, which in this case is $8. And the second constraint is the margin is 10%. We cannot go less than that. So to do that, so this is the formula for the first one. So if K11, which is the cost, K11 is the cost, divided by zero point 0.3, which is 70%, is greater than or equal to K16. K16 is the computer sales price. Then in that case, put the computer sales price, which is $8, or it should be K11 divided by zero point 0.3, which is a 70% margin. Okay. And the second constraint formula is pretty simple. K11, which is the cost price, divided by 0.9, and that is the sales price with 10% margin. Now, assumption is made, the constraints are set. Now let's see how do we solve this problem. So first we would like to see how the demand equation looks like. So to do that, I'll be selecting this range, these two data sets. One is the price and second is the quantity. And then go to insert and draw a scatter plot. So once we draw the scatter plot, we can see 3 points. So we right click and we press add trend line and we make it polynomial so that all the points are touched. And we also would like to display the equation, which is a demand equation on this chart. So I just click it. Now we can see an equation, which is this. Now what I would like to do, I would like to get these coefficients here. So one way is that you simply type it in. But if you type it in, then since these numbers are pretty big, so it's going to be prone to error. So, and also if these values are changed, so this equation will change. And again, I have to retype. So the best way is to use a formula, and that's an array formula. I'll be just showing that to you now. So you come here and equal to linest open parents, and then we take the first data set, which is this, comma, the second data set, and then we are going to put to the power and then curly bracket. Now, since this is a second degree equation, we'll put 1 and 2, and the curly bracket is closed, and the parenthesis is closed. And then we press enter. Now you see, these coefficients are spilled over here, right? It's a nice way. We don't have to type it. So all these big numbers have automatically come here. Now, in order to do this calculation, I need the unit price, which we are going to optimize later. But for now, what I've done, this cell equal to K10. So K10 is basically the unit price of shampoo C. So I've just put that, which is going to be later optimized, but for now, let it be 6.70. Then I will be calculating the quantity using this equation. So what I need to do, equal to this coefficient multiplied by price, see this equation, and then to the power 2 plus this coefficient multiplied by the price to the power 1 or nothing, and plus the third coefficient without any price component. Okay, so the quantity is 60,000. Now I'll calculate the revenue. So revenue will be simple, the quantity multiplied by the unit price, which is this. I've already set this cell for the currency, so we can see a dollar sign, and the cost is going to be, the total cost is going to be quantity multiplied by the unit cost, and unit cost is $3. And the gross margin is going to be revenue minus total cost. Now this is the gross, 222,000. 222,000. Now, everything is set. Now, what we need to do, we have to optimize this price, which is currently 6.70, in such a way that my gross margin, which is currently this, is going to be maximized. So to do that, I will be using now Solver. Now, for that, you have to go to this data and then go to Solver. Now, if you don't have Solver, because it doesn't come as a standard add-in, so you have to go to File, and then you go to Options, and you go to Add-ins, and then since it is an Excel add-in, you see Excel add-in, and if you say Go, you can see Solver add-in, which needs to be checked in. So in this case, it's already checked in, so I just don't have to do anything. So it's already there. And then I'll be invoking this Solver. Now, what I need to do now, this screen is totally blank. So first of all, I need to set an object. So what is my object cell? My object cell is gross margin, which is this one, which we have to maximize. So I will just put my cursor here. So N23 is my object cell. And to what? So I have to maximize it. So I put that into max by changing the variable cell. Now, which cell which value we are going to optimize? That's the price, which is this cell, which is N19, correct? So we have to maximize N23, which is gross margin, by optimizing N19, which is the unit price. Now we have to add the constraints. So first we go to add, and what is our first constraint? Our first constraint is this price, which is the unit price, cannot be, it has to be less than or equal to $8. Remember, this is the first constraint we have set, where it cannot be more than, the margin cannot be more than 70%, and that's, we got it $8. So this cell. And then our second constraint is this. So we will add, and then again we go to this cell, which is the unit price, which is N19, and now in this case it's going to be greater than or equal to the price with 10% margin, which is this cell, which is 3.33. So my both the constraints are set, and I press OK. Now my object cell is set. My the cell which I'm going to optimize is set, and the constraints are set. Now I have to press this button, solve. So it will take some time to solve, and we will wait. Yes. Now this screen says the solver has found a solution. Do you want to know the result of the solution? So there's an option which is keep solver solution, which is by default checked. You press OK. And when you press OK, and you just have to go to this cell and just press it, now you see 6.97. So previously, if you remember, our margin was 222,000. But now with 6.97 price, the margin has been increased to 224,602, which is the maximum margin. But you see, the quantity is reduced. So previously, with 6.70, the quantity was 60,000. Now the quantity is 56,558. So that means you're selling less. And even the revenue is reduced because previously the revenue was 402,000. Now it is 394,276. So even though your quantity is reduced, your revenue is reduced, but you're still making the more margin because you have a higher price, which is 6.97, and 6.97 is the most optimum price to get the maximum margin. So this is so you can so like gross margin, if you want your revenue to be maximized, you can set your object sale as revenue. But since most companies are after the margin, so I've set the margin as a target sell. So this is what the solver is all about. Guys, if you have liked the video, please subscribe it and hit the bell button. And I'll shortly be coming with more videos. Thank you very much.